This time we're writing an expression as a single logarithm. This is Alex's homework topic, writing an expression as a single log. And in this example, I have three separate logs, but what I'm liking is that all of their bases are 6, 6, and 6. They are the same. So that means I can combine these and write this as a single log of base 6. So this is the first step. What you're going to do is you're going to bring any of these exponents that are in front of it. And I know I called it exponent because they used to be exponents. You're going to send them to the top, okay? You're going to send them back to where they may have came from. So this 1/4 will become the exponent of y. This 3 will become the exponent of x. But notice that this last term doesn't have a number in front. So y does not have an exponent. So here's my first line. Okay, here's my first line. Log space 6 of y to the 1/4 power plus log base 6 of x to the 3rd power minus log base 6 of y. Now let us combine these three logs and put it together, okay? I'm going to write this as a single gigantic log base 6. And I'm going to make this a fraction because this term right there has a minus sign, so that's going to go to the bottom. So when you put all these together, we just put the arguments. So y to the 1/4 power, x to the 1/3 power will be on top of the fraction. Y to the 1/4 times x to the 3rd. But this y will go to the bottom of the fraction because this log expression has a minus in front. But you notice the first two are positive, so that's why y to the 1/4 and x cubed are on top of the fraction. Now, this looks almost done, but it's not really done just yet because you notice there is y to the 1/4 on top and y to the 1st power in the bottom, right? So what we're going to have to do is we have to simplify these. So what's that going to be? What will happen when you divide y to the 1/4 power divided by y to the 1st power? You're going to have to subtract their exponents, okay? So if I do y to the 1/4 power divided by y to the 4/4 power, because I'm trying to subtract their exponents, 1/4 minus 4/4 will give us -3/4, okay? So I can write this as log base 6 of y to the -3/4 power times x to the 3rd power. That's a perfectly fine answer, but sometimes they don't want you to write using a negative exponent. Well, in that case, you're going to have to send that y to the bottom because as a negative exponent, right? So what you will have is x to the 3rd power staying on top, but y to the 3/4 power in the bottom. But when you send it to the bottom, it becomes positive. Now, what was difficult about this problem? Again, not the log property. It was working with the exponents because we had to simplify. Y to the 1/4 power divided by y, right? When you had to simplify that, you had to remember that dividing power involves subtracting the exponents. And when the exponents were fractions, we had to quickly remember how to subtract fractions and just remember that whenever it has a negative exponent, we can send it to the bottom. So what makes pre-calculus difficult, I think, is not because of pre-calc topics and a new topic, but we have to remember so much algebra and basic things like fraction skills from a long time ago. So that was one example. I'm not sure which one will be. I think both should be acceptable in your homework, but let's see if I have another one similar to this. All right, let's try this one. Write the expression as a single log. So what we will do first is whenever it has number in front of these log, we're going to send it to the top. Okay, we're going to make these an exponent of those log arguments. Okay, so the first line looks like this. Log base 4 of w minus 2 to the 3rd power minus log base 4 of w plus 6 to the 6th power. Okay, now I'm going to put them together. Log base 4 of w minus 2 cubed over w plus 6 to the 6th power. And I think I would just stop there. I mean, what else can we do, right? Unless I don't think we should go on. I think that's it. There's nothing else we can really do because w minus 2 is a subtraction and there's no property such as difference property or sum property of log. There's a product property and difference property, but these are connected by minus sign and plus sign as arguments, so we can't really go any further. So I would go ahead and type this as the answer. Maybe we just don't need those outside parentheses. But for me, I feel like this one was a little too simple. But I don't think we will sit here and raise this to the 3rd power, FOIL it, or So this will be it. This will be it. So when you do these condensing homework problems and see something that is very different, or if you want me to review some exponent properties with you, I'll take a picture of it for me and send it to me so that I can review that for you. I think I just have one more left, so I'll go ahead and finish this up. So what I will do is I will send this exponent, I keep calling it exponent, these numbers that are in front, these coefficient, up. These will go up. And they will become an exponent for the entire argument. So I will have, you know what? No. I almost messed up. You see, the second one is fine. But if you look at the first one, this is a log base a minus y, and that's another separate log. So, instead of sending this up as an argument, what I will do is I will distribute this 3 first. I'll distribute this 3 first. I will get 3 times log ay minus, now I have to multiply this 3 times 5, right? That will be 15 log base a z, and then I will bring that 3 up, so I'll get log base a w cubed. Okay, now I'm going to bring these 3 and 15 up. Okay, so I'll get log a of y to the 3rd power minus log a of z to the 15th power plus log a of w to the 3rd power. Alrighty, let's go ahead and write this as a single log base a. Now, I'm going to have to draw a fraction. Anytime the log expression has a negative, it's going to go to the bottom. Y cubed and w cubed has positive sign in front, right? So I'm going to have y cubed on top and w cubed on top. But look, this z to the 15th power, this has a negative sign in front of this log term. So guess what? We're going to have to put that in the bottom of the fraction. So that's it. That is how I will simplify this expression. This is a single log. And I will stop this lesson right here, and that's it.